Yeah, dear all, good morning. Now our lecture is 20th. In this lecture we are going to discuss norm of a vector and angle between two vectors. So last class we discussed norm. Using that norm we are finding norm of a vector and angle between two vectors. With respect to that norm, first we discuss what is the norm of a vector. See, we know this u comma is positive for all u non-zero. If u is equal to 0, this is 0, already we discussed, that's the definition. We use inner product to define length of a vector. So, what is the definition? Let V be a vector space over F, that field, then for any vector u belongs to V, we define the length or norm of a vector, which is a notation denoted by norm u. This is square root of u comma v. So, positive square root. So, a vector of norm 1 is called a unit vector. That means u by norm u is called the unit vector in the direction of u. Unit vector in the same direction of vector. Some small theorem. Let V be on inner product space and u belongs to V. Then for any scalar alpha, norm of alpha u is same as mod alpha into norm u. The proof is simple. So norm of alpha u square. So norm of alpha is square root. This square equal to this one. That inner product. Alpha u comma alpha u. This equal to, so now using definition, the first element is same, you write outside, this one writing conjugate, u comma u. Alpha into alpha bar is mod alpha square, this is u comma u is norm u square, the same as mod norm alpha u equal to mod alpha into mod u. Because these all are positive, since all are positive, all are non-negative terms. Non-negative terms. These all are non-negative terms. That's why we can write the square root to cancel. This is the one. Now we will see some example. Suppose take example. Suppose let some vector u is 1 comma minus 1 comma minus 2 3. This belongs to r power 4. So then, what is the norm of u? Norm of u means length of a vector. This is equal to, see already you know this inner product, just I give idea. See suppose u equal to u1 u2. See what the inner product u comma u inner product is the u transpose u. That is a multiplying u and u transpose. That means we get u1 into u1 square plus u2 square. For two vectors. For n vectors we get u1 square plus u2 square and so on. But norm u means square root of this one. That means square root. See, if it's not mentioned any inner product, that is a standard inner product. That means we get 1 into 1, 1 square, plus minus 1 into 1, minus 1 square, plus minus 2 into minus 2 square, plus 3 into 3, 3 square. This is the one. This is equal to the root 1 plus 1 plus 4 plus 9. This is the root 15. And so on. See now, observe here, the vectors u over root 15 and minus u over root 15 of norms. Norms are length. Norm c is 1. These two vectors length is 1. Take u by norm u or minus u. If you multiply this one also, you get same length. That unit vector is norm is 1. Both are unit vectors. Therefore, thus u by root 15 is a unit vector. Is a unit vector in the direction of u. So u by root 15 is a unit vector in the direction of u. Length means in the norm value under root this one with a standard inner product. So next going to define angle between two vectors. First we define some inequality. This is a cos is coordinate equality theorem. Let V be an inner product space over F. Then for any u comma v belongs to V, mod of u comma v less than or equal to norm u, norm v. See moreover, suppose this equality holds in inequality, if and only if u and v are linearly dependent. Already you know linear dependent concept. We'll see. See, now this proof is simple. Proof. See, now suppose if u equal to 0, then equality holds in inequality. That equality hold. Equality hold. See what one. If u equal to 0 means what is the mod of u comma v? Is equal to mod u is 0. V is any vector. We know this is equal to 0 for all v belongs to v. V belongs to v. And suppose you can take norm u into norm v. That u is 0 vector. That means 0 norm into norm v. 0 norm 0 means 0. 0 into v means 0. That means therefore u comma v equal to norm u into norm v. That any vector is 0, it's 0. See, one vector is 0, that's a linearly dependent. Okay, we can go for another way also. Yeah, one vector is 0, that equal to holds. That means linearly dependent. See, now, next, suppose if u not equal to 0, u not equal to 0, then I am taking lambda u plus v, comma lambda u plus v. That means the length, that's a norm, it's always positive for all lambda belongs to any field and v belongs to vector space v. In particular, suppose I am taking this lambda is minus v comma u divided by norm u square. I am taking this one. Some particular case. So now what is the inner product? This one we know it's a positive. This is 0 less than or equal to lambda u plus v comma lambda u plus v. Now write this inner product using the definition. Lambda u into lambda u, lambda into lambda bar. First element is lambda, second is lambda bar. So u comma u. Next plus lambda into v. The lambda is first element, lambda u comma v. Plus next v into lambda is for second element. This one you can write lambda bar v comma u plus v into v. That is v comma v. This is equal to, now what is the lambda? Lambda is minus v comma u and the lambda bar is minus v comma u bar. That minus plus we will get this is the v comma u by norm u square into v comma u conjugate by norm u square into u comma u is the norm u square. We can write this one. Lambda is minus v comma u by norm u square into u comma v. Lambda bar means minus v comma u conjugate by norm u square into v comma u plus v comma v, that's a norm v square. So now observe here, see, observe here, this one norm u square is cancelled. So now v comma u and v comma u conjugate bar. Here observe here, v comma u and v comma u conjugate bar. This is v comma u conjugate bar and divided by norm square. This term is cancelled. Now write a remaining term. What are the remaining term? Norm v square minus this is the v comma u by norm u square. So v comma u comma v. See v comma u comma v. This is v comma u comma v. Can write it's a mod v comma u square. Since u comma v square. Since u comma v same as comma v same as v comma u conjugate. V comma u conjugate can write u comma v. This is v comma u conjugate. Sorry. You have to write u comma v. See. That means u comma v. See that okay. U comma v we can write u comma conjugate equal to v comma u. V comma u is u comma v conjugate. See u comma v conjugate and u comma v. That's a mod square. That is z into z bar, like z into z bar equal to mod z square. That's why apply that one. See now observe here. Now take this multiply with norm u square. We will get norm u square into norm v square minus mod u comma v square. It's greater than or equal to 0. This implies this one you can write. If I write this one side, this is mod u comma v whole square in less than or equal to norm u into norm u square into norm v square. But this all are positive terms. That means u comma v mod less than or equal to norm u into norm v. Since all are non-negative terms, non-negative terms. So all are non-negative terms. Therefore, this one correct. So now this is the inequality. See, we are using this in particular equal to holds. That means this equal to hold. Equal to hold means lambda u plus v equal to 0. Note that equality holds. Equality holds. Equal to hold in inequality. Inequality. If and only if they are linearly independent. If and only if and only if lambda u plus okay, if and only this one you can write. If and only if lambda u plus v equal to 0. If and only okay, you can write this one. If and only lambda u plus v comma lambda u plus v equal to 0 or equality equivalently lambda u plus v equal to 0. Yeah, this one. Hence, when that inner product is 0, one vector is 0, the vector is 0. Hence, u and v are for linearly independent. LD, linearly dependent. Yeah, moreover, see, linearly dependent means 0. This equal to I write 0 comma v. That is 0 comma v. 0 means this one lambda u plus v. This equal to lambda u plus v into v. This equal to lambda u comma v plus v comma v. That means lambda equal to minus sorry, we take suppose you take here u, both are take u is non-zero. U lambda equal to this is u comma u. This is v comma u. That is lambda equal to minus v comma u divided by u comma u is norm u square. Norm u square. Yeah, therefore, See, now observe here this lambda u plus v equal to 0. Yeah, here we are writing v equal to lambda u plus v equal to 0. That means we are writing v equal to minus lambda u. See, one vector is scalar multiple of another vector. That means they are linearly dependent. That's why we are writing equivalently lambda u plus v equal to 0. The same as you can write, if I write this one, lambda equal to this one, minus lambda is v comma u by nam u square into nam u square. No, v comma u into u into u. The same as you can write v comma u by nam u into u by nam u. That means unit vector like this one. Yeah, that means v equal to some number, this is some non-zero scalar into v equal to scalar into u. That means they are linearly dependent. This one. Some examples. See, now take one. Suppose let a comma b greater than 0. Okay, we will discuss this one later. There is no place. Okay, a comma b greater than 0. Then a plus b greater than 2 equal to this arithmetic mean greater or equal to geometric mean. What the geometric means? Root ab. Yeah, this one we can prove by using this Cauchy-Squarge inequality. Now how to prove? Solution. Define u equal to root a root b and v equal to root b, v equal to root b root a. It's correct, root b root a. Okay, then what is inner product of uv? This is u transpose v. This is equal to u transpose v means this multiply root a into root b. Multiplying this one, root a into root b, ab plus ba. Okay, root a, ab plus ab, that means 2ab, ab plus ba, this is 2ab, and nam u equal to under root a square root b square, a plus b, and nam v square equal to root b square, that is root ab. See this one. Now by Cauchy-Squarge inequality, by Cauchy-Squarge inequality, what we have? This mod of u comma v greater than or equal to nam u into nam v. That implies u comma v. What the u comma v value is? Mod of u comma v is mod 2ab less than or equal to nam u. What the nam u equal to? Under root a plus b, and nam v is under root a plus b. Under root a plus b into under root a plus b is a plus b. That implies that a plus b divided by 2 greater than or equal to ab. That means arithmetic mean greater than or equal to geometric mean. By Cauchy-Squarge inequality. This one. Okay, we'll see now define angle between two vectors. See, let V be a real vector space, then UV belongs to vector space. The Cauchy-Squarge inequality implies this one the one, because what the Cauchy-Squarge inequality? Mod u comma v less than or equal to nam u into nam v. See now, if you remove this mod, this is lies between minus 1 to 1. That's one. If you take one side, this one you can write mod u comma v divided by norm u norm v less than or equal to 1. But if you remove mod, this is lies between minus 1 to 1. We use this together with the properties of the cosine function. Already we studied cosine function to define the angle between two vectors in an inner product space. This is the definition. Let V be a real vector space. Theta belongs to 0 to pi because it's minus 1 to 1. So lies between 0 to pi. Pi value is minus 1. In the angle between u comma v belongs to v minus 0. That is, it's not a 0 vectors. Then we define cos theta equal to inner product of u comma v divided by norm u into norm v. For standard inner product, we can write cos theta equal to, suppose u comma v are in Rn space, we can write u1 v1 plus u2 v2 for standard inner product un en divided by under root. Suppose in R3, okay, right, only R3, mostly we are taking R3. For R3, for standard inner product, not every inner product, u3 v3, this is equal to u1 square plus u2 square plus u3 square, u2 square plus, sorry, v1 square plus v2 square plus v3. Already used this formula in PUC for finding angle between two vectors or two lines. See now, we'll see some examples. Suppose take 1 comma 0 transpose and 1 comma 1 transpose belongs to R2. Then cos theta equal to, what the cos theta is? That inner product of 1 comma 0 1 1. But it's not mentioned in inner product. Now you have to take standard inner product, norm of that 1 comma 0 norm of 1 comma 1. No need to write formula, directly you can take. This is what the inner product, standard inner product means the multiplication 1 into 1, 0 into 1, that is 1 divided by length of this one 1, length of this one 1 plus 1, 1 square plus 1 square, so 1 by root 2. Or the cos theta equal to 1 by root 2 means theta equal to 45 degrees. This one. Suppose I take second example. Take this one. Suppose 3 vector 1 0 minus 1 1 0 1 and transpose 1 comma 1 comma 1 transpose belongs to R3. Then cos theta equal to, now inner product of this one, standard inner product 1 into 1 1 plus 0 into 1 0 plus 1 into 1 1 divided by under root 1 plus 0 square 1 plus 1 square 1 root 1 square plus 1 square plus 1 square 1. So 2 divided by root 2 into root 3, that is 1 by 2 into the 1 root 1 square root cancel, that is 2 1 that is root 2 by 3. Yeah, therefore theta equal to cos inverse root 2 by 3. This is one. So, the angle depends on the inner product. Suppose take third example, the angle depends on the inner product. Angle depends on the inner product. So what, take this one, same example, first example, take 1 comma 0 transpose 1 comma 1 transpose belongs to R2. Find angle with the inner product, u comma v 2u1 u2 2u1 u2 plus v1 u1 v2 plus u2 v1 plus 3 v1 v2. Suppose it is asking like this one. This is inner product. You can check this matrix one. They are asking find the angle between this with this inner product. For this inner product, suppose take this is the u vector, this is the v vector. Now first find u comma v. What is the u comma v? Alright, solution. What is the u comma v? The inner product of these two vectors. This is u transpose v. That is equal to 1 0 and 1 1. This is the 1 plus synonym. Now you have to use this inner product. Now use this inner product. Okay. You have not used the general inner product. You have to use this inner product. See now here 2 into u1 u2 u1 1 0, that is 1 into 0 0 plus u1 v2 u1 is 1 v2 is 1, that 1 into 1 1 plus u2 v1 u2 0 with 0 plus 3 into v1 v2 v1 v2 is 1, that is equal to 1 plus 3 4 and nam u. What is the nam u square or nam u? Nam u equal to square root of that one. Okay, write nam u square first. What is the nam u square equal to? 2 into u1 see. What is the total u1 u1? That will be 2 u1 square. u1 square is 2 plus u1 v2 u1 u2 0 u2 u1 0 plus 0, that is 2. And nam v square, that means 2 v1 v2 2 v1 v2 means 2 1 plus u1 v2 is 1 u2 v1 is 1 plus 3, that means 5 7. Therefore cos theta the angle theta, okay, angle theta between given vectors is cos theta equal to what the nam u comma v divided by nam u into nam v. This is the formula. This is equal to nam u v, that is the 4 divided by nam u. Nam square is 2, nam u is root 2 and nam v, this, okay, this one you can write nam u equal to root 2 and this is nam v equal to root 7, that is the root 7. Whatever this one you can write 4 is there, so 4 by root 40, yeah, this is the one. Therefore theta equal to cos inverse 4 by root 15. See now observe here, with the same vectors you find out angle between these vectors with standard inner product, we got 45 degrees, but with another inner product, different inner product, we get different angle. That's why angle depends on the inner product. This is the main thing. Angle depends on the inner product. Now try an example. Try this one. Find angle between the vectors one, two, 3. Find this one. It's not mentioned inner product, that means you go for standard inner product and find angle between the vectors 1 comma 2 transpose minus 1 3 transpose belongs to R2 with one inner product take this is u, this is the v. The inner product u comma v equal to 2u1 u2 minus u1 v2 minus u2 v1 plus v1 v2. Now try these two problems. So now triangle inequality. Let V be an inner product space over F. Then for any u comma v belongs to V, it's norm of u plus v greater or equal to norm u plus norm v. Already you know this triangle inequality. It's a proof. It's simple. We can prove this by inner product space. So let's take norm of u plus v whole square. This is equal to u plus v comma u plus v. Now write the use the u comma u plus uv u comma v plus vu v comma u plus vv v comma v. This is equal to u comma u is norm u square, u comma v and v comma u. This one can write u comma v conjugate plus norm v square, norm u square. So you know when that z plus z bar equal to 2 into real z. And this one you can write 2 into real part of u comma v plus norm v square. So this all are two real parts. Because this norm is length, number, real number. This is also a real number. This one you can write 2 into real number. This v and u comma v inner product. This is can write norm of u plus norm of v whole square. Yeah, therefore, this is equal to, but this is the same as norm u plus v whole square. So these all are positive terms. This implies you can write norm of u plus v equal to, okay, this is a less than or equal to, okay, right. Okay, sorry, this is equal. Okay, this one you can write less than or equal to norm u square plus 2 real part we can write 2 into norm of u comma v. Okay, 1 minute. So now here, okay, this is the 2 real part. So now, okay. So this is equal to norm u square. This is the u plus z bar is 2 into real part of u comma v plus norm v square. But we know 2 real part. This is less than or equal to norm u square plus 2 into u comma v, 2 into u comma v plus norm v. Plus norm v square. Yes, since you can write z plus z bar equal to 2 real of z less than or equal to, less than or no equal, sorry, this is equal, we know this one. Yeah, here this is equal. Yeah, but by Cauchy-Schwarz inequality, this is less than or equal to norm u square, this is less than or equal to 2 into norm u into norm v plus norm v square. You can add by, since by cos is squarge inequality. Squarge inequality. This is the same as you can write norm u plus v whole square less than or equal to. This is you can write norm u plus norm v whole square. But these all are positive terms, that means non-negative terms. The same as norm u plus v less than or equal to norm u plus norm v. You can write since all are positive terms, all are non-negative terms. Negative terms. That's one. See now, yeah, this is the triangular inequality. Now try this one. Norm u minus norm v mod that are equal to norm u plus norm v. Try this inequality. Try this one exercise. It's a simple. Take first norm u. This one, just I give idea. This one, take norm u. Norm u can write norm of u plus u minus v plus v. By triangular inequality, this one can write norm of u minus v plus norm of v. This minus u minus v, this one. Yeah, this one we can write. So that means norm of u minus norm of v equal to less than or equal to norm u minus v. Now next to take norm v. Norm v equal to write same thing. We get norm v minus norm u equal to this inequality. If you take mod, minus one is minus one is plus one. Take that's a mod. This mod less than or equal to norm of u minus v. Try this inequality. Another inequality, parallelogram law. See now it's parallelogram law. The proof is simple, same thing. Try this parallelogram law, same procedure. Take norm u plus v and norm u minus v. Same way. Try this parallelogram law. I give one some property, some example. Let a comma b greater than 0. Let a then this a plus b 1 over a plus 1 over b greater than or equal to 4. See now this one. See now define u equal to solution. Define u equal to root a root b and v equal to 1 over root a 1 over root b. Then 1 over root b 1 over root a. This one will get root a root b 1 over. See now what is the inner product of u comma v? This is u transpose v. What is u transpose v? Root a cancel. That's a 1. Root b cancel. That's a 2. This one. More and what is the norm of u comma u? Or norm u square or norm u. What is the norm equal to? Square root of root a square and root b square, a plus b, and norm v equal to square root of this one is under root 1 by a plus 1 by b. This one by cos is squarge inequality. We have mod of u comma v less than or equal to norm u into norm v. This implies mod of u comma v is the 2. Yeah, mod 2 no need to write. Norm u is the under root a plus b. Norm v is the under root 1 by a plus 1 by b. This mar root is same as 2. Now squaring both sides, you will get 4 less than or equal to a plus b. It's a 1 by a plus, square root is cancelled, 1 by b. That is a plus b into 1 by a minus 1 by b greater than or equal to 4. Yeah, try this inequality for more than 2 numbers. You can go for n numbers also. Yeah, same as that arithmetic mean, geometric mean, you can go for more than 2. If interested, try for more than 2 elements. Yeah, that vector is more than that nth space or R3 space or R4, whatever you take. If you take any 2 vectors in any space, I am taking R2 space. If you take Rn space, you can prove this inequalities. Okay, I am stop here. Thank you. Try this inequality, parallelogram law, and some example.